Good morning, and welcome to today's webinar focusing on the changes to ASTM F963, the Standard Consumer Safety Specification for Toy Safety. I'm Carolyn Helda, the Managing Director of AI and SECO here in Buffalo, New York. Presenting with me today is Chris Gohler, who is our Manager of Global Programs and Client Services. We have about 45 minutes scheduled to review the key changes from the 2011 version of the standard to the updated 2016 standard. We will leave about the last 10 or 15 minutes to go over some questions that we received during the webinar. Note that all webinar attendees are muted, so please use the questions window to submit your questions, and we'll address as many as possible during the session. For those questions we can't get to, we'll answer via email after the webinar. Before we begin, I'd like to tell you a little bit about AI and SECO. AI and SECO is a division of Asia Inspections, and we're a global quality control company that partners with brands, retailers, distributors, and importers to secure and manage their global supply chain. We offer a variety of audit and inspection services, and we specialize in testing all types of consumer products. With laboratory locations in the U.S., Hong Kong, and China, coupled with our audit and inspection services in 77 countries, we can be your one-stop shop to fully address your quality, safety, social, and regulatory compliance concerns of the products that you manufacture and source. With that being said, let's begin with a quick introduction of the ASTM F963 standard itself before discussing the revisions. First of all, the purpose of the ASTM F963 standard is to establish a nationally recognized safety requirement for toys. Prior to the Consumer Product Safety Improvement Act of 2008, or CPSIA as it's commonly known, the ASTM F963 toy standard was considered a voluntary standard. However, as precipitated by the growing number of product recalls and injuries associated with toys, ASTM F963 became a mandatory standard with the passing of CPSIA. As part of the requirements detailed in the standard, testing criteria are established that are in many cases based on the appropriate age grade of the product to ensure that it is tested in line with the way the product will be used and perhaps misused by a child. The standard also sets requirements for product and packaging labeling, as well as instructional literature to give adult caregivers to guide adult caregivers when they're buying product or engaged in using the product. All of the requirements are aimed at reducing the hazards associated with the normal use and the foreseeable misuse of toys. In order to understand the standard and its application, it's first important to know the definition of a toy. Per the F963 standard, a toy is defined as any object designed, manufactured, or marketed as a plaything for children under 14 years of age. This definition differs slightly from the requirement under CPSIA, which sets the age for a children's toy at 12 years and under. Please note that not all items designed and intended for children are classified as a toy covered by the F963 standard. Items that are not covered by the standard include products such as bicycles, playground equipment, and arts and crafts material, as long as the arts and craft kit does not produce a finished item that is a toy. Also, real sporting good items are not considered a toy. However, their play counterparts, such as a plastic, oversized bat and a ball, would be considered a toy. So now that I've provided a brief introduction of the standard, let's review the key changes that you'll find in the revised 2016 version. As we go through the revisions, keep in mind that the CPSC has stated the effective date of the federal rule based on any updated version of the toy standard applies to the date of manufacture of the product, not to the date that it enters into commerce. So if you're importing product into the U.S., be sure to check the date of production and confirm if the product needs to comply with the new standard based on that date. Also, if you have a copy of the new standard, please note that ASTM will be publishing a new version shortly to correct some minor editorial concerns. The ASTM F963 Standards Committee has worked very hard over the years to ensure that the standard continues to evolve and grow as more diverse and complex products are introduced to the market. The changes to move to the 2016 version are focused on some of the chemical, microbiological, physical, electrical, magnet, and labeling requirements. Based on the date that ASTM formally notified the Consumer Product Safety Commission of the new version of the standard, which is November 1st, the timeline for implementation is expected to be April 29, 2017. The CPSC has 90 days to review and approve the standard, so they need to make their decision before January 29th. The revised standard will be effective 90 days after the CPSC approves the changes, thus replacing the current F963-11 version as the mandatory regulation under CPSIA. This 90-day time period gives manufacturers the opportunity to make any necessary product modifications and perform pre-testing to help ensure that they will remain compliant. The first section that we're going to focus on is the change to chemical requirements, of which there are very few. Currently, the ASTM F963-11 standard allows for the use of high-definition X-ray fluorescence spectrometry, or HDXRF, to test for lead in homogeneous non-metal and metal substrates materials for compliance to the 100 parts per million total lead limit, and this is an alternative to the approved wet chemistry test method. This new requirement under F963-16 will extend the use of HDXRF as an alternative test method to screen homogeneous polymers for all 8 heavy metals regulated by the standard. Those metals would be antimony, arsenic, barium, cadmium, chromium, lead, mercury, and selenium. Again, this is only for homogeneous polymers, which would include common plastic resins used in the manufacture of toys, such as ABS, polyethylene, and polypropylene. Using XRF does have advantages, such as the fact that it can be performed on a smaller sample size and the testing is non-destructive. However, if the screen comes back with a fail or inconclusive result, then wet chemistry would be needed to conduct those components to confirm whether they are compliant. Additionally, each component is tested individually with XRF. The methodology does not allow for composite testing. Under Title 16 of the Code of Federal Regulations, Part 1500.91, which is a rule promulgated under Section 101 of CPSIA, there are specific material exemptions allowed for lead testing, such as wood, CMYK processing printing inks, and textiles composed of dyed or undyed natural or synthetic fibers. Updates in the ASTM F963-16 standard clarify that these material exemptions extend to the soluble lead requirement in addition to total lead. However, most of the listed materials remain subject to the substrate limits for other soluble heavy metals specified by the standard. Notwithstanding this, paper and paperboard are exempt from substrate testing for all elements. With the 2016 version, ASTM has also provided clarification about other materials, such as stickers, textiles, and metallic toys or metallic toy components. For stickers on paper substrates with no laminate coating, it was clarified that they are also exempt from substrate testing for all heavy metals. However, if a sticker is printed on a plastic or other non-porous substrate, or has a laminate plastic coating, the sticker must be tested for heavy metals. Printed stickers that do not have a scrapable surface coating are tested as a single polymeric material. If a scrapable surface coating is present, that would be tested separately from the substrate. For textile materials, the new standard clarifies that if printing can be easily separated from the textile, it must be tested for heavy metals as a surface coating. And lastly, in regard to metallic toys and metallic toy components, the new standard clarifies that if the product meets the 75 parts per million total screen for cadmium, it is considered compliant and it does not have to undergo further testing by the extraction test. Moving on, let's talk about the revisions to the microbiological requirements. The 2016 version of ASTM F963 expands the scope of microbiological safety requirements by adding a new category, items of avian feather origin. This was done since products like feather boas that you would find on a children's dress-up set may potentially exhibit high microbial loads or the presence of pathogenic organisms or both. Since these feathers come from various birds, like turkeys, they must be treated properly before use in a product to ensure they are not contaminated. To provide additional test protocol options for microbiological cleanliness testing and the microbial challenge test, the revised standard allows for the use of the CTFA Microbiology Guidelines, which stands for the Cosmetic, Toiletry, and Fragrance Association. This was chosen because the methods are designed specifically for cosmetic products, which are more similar in nature to the relevant materials found in toys. Alternatively, the USP, or United States Pharmacopoeia methods, may still be used, and these were developed for pharmaceutical products. Products that will be subjected to microbiological testing under the standard are children's toys that contain liquids, paste, putties, gels, and powders. And this would include things like toy cosmetics, bubble solution, and play sets that contain sculpting dough. The revised standard also sets microbial limits for cleanliness of materials and preservative effectiveness, as well as provides clarification regarding the microbiological requirements for processed water. We'll take a closer look at these requirements on the next slides. Here we are illustrating the microbial limits that have been set for various categories of toys. As you can see, the lowest limits are set for products that are appropriate for the most vulnerable population, infants. Also, the lowest limits apply to products intended for use on the face, such as children's toys cosmetics. In addition, products that are subject to this requirement must not contain specific pathogenic organisms. The pathogens include E. coli, Pseudomonas, Staphylococcus, and Salmonella species. Also, the absence of Shigella species must be verified for avian feathers. Preservative effectiveness testing, also known as microbial challenge testing, is an important test for aqueous products to help ensure that they will not support the growth of microorganisms throughout their shelf life and useful life. The F963-11 version references USP 51 as the method for testing. However, the F963-16 version also allows for the use of methods M3 or M6 from the CTFA Microbiology Guidelines. The revised standard clarifies that there are some classes of product that do not have to be tested for preservative effectiveness, as the nature of the product will not support microbial growth. These are generally products with a lower water activity or non-aqueous products such as lip balms, also products with an alcohol content of 20% or greater, and products that are considered too acidic or alkaline to support growth. In addition, avian feathers are specifically excluded from the requirement to test for preservative effectiveness. I mentioned that the CTFA Microbiology Guidelines were chosen as an alternative test protocol for cleanliness of materials and preservative effectiveness in the revised standard. Additionally, the new standard provides more clear and specific criteria for testing, such as defining the sampling interval as well as the evaluation criteria. A minimum list of organisms that must be used for the testing, they are identified in the revised standard. These organisms include common pathogenic bacteria, as well as yeast and mold that could potentially be introduced into the product, and if they were allowed to grow, would impact the product's integrity and safety. The last component for the microbiological changes address processed water. This is the water that's used in the manufacturing and filling of toys, and it must comply with the bacteriological standards for USP purified water, as well as for drinking water per the Environmental Protection Agency. Specifically, this requires a heterotrophic plate count of less than 10 colony-forming units per milliliter and the absence by test of coliform bacteria. Now I'm going to turn things over to Chris, who will review the revisions to the physical testing requirements in ASTM F963-16. Chris?
Thanks, Carolyn. Now that Carolyn has detailed the chemical and microbiological changes to the ASTM F963-16 standard, I will review the physical, electrical, magnet, and labeling changes. As we know, this standard is packed with a number of changes, so let's begin. I do want to remind everyone that you can submit your questions using the questions window, and we will try to address as many of those as possible at the end of the presentation. First, we will focus on the changes to the stuffing material evaluation. The new standard has removed the Pennsylvania state requirements, which mandated that manufacturers must submit detailed information as to the filler content of their stuffed toys. The Pennsylvania regulation includes a flammability requirement as well as a list of materials and chemicals that, if present in the stuffing material, would classify the stuffed toys as unfit. This has been simplified with the new standard, as a visual inspection is allowed using the specified stereo wide field microscope or equivalent apparatus. Although this requirement has been removed from the ASTM standard, currently stuffed toys must still meet the Pennsylvania statute if sold or distributed in the state, or they will be considered unfit for sale. The acoustics section of the standard details testing requirements for noise-making toys. The format and sequence of the methods section was revised to clarify the testing process and present the procedure in a similar manner to harmonize with EN 71 Part 1 and ISO 8124 Part 1. As such, there is no longer a distinction between continuous and impulsive sounds. While the concepts of continuous and impulsive sounds are still critical in establishing the correct decibel limits, F963-16 eliminates the need for the testing lab to make a determination as to whether a sound is continuous or impulsive. The standard adds a definition for push-pull toys to clarify that the reference testing criteria applies to toys intended for use on the ground with the child standing in an upright position. The standard was clarified to provide a clear understanding of the scope of this type of toy and to limit confusion that has arisen over the years. You will also notice that the speed at which the push-pull toy is operated to produce a maximum sound level has been lowered from 2 meters per second to 1 meter per second. The speed in the previous standard represented a worst-case scenario that would typically not be achievable for most children and products. Finally, on this slide, the standard also raised the C-weighted peak limit from 95 decibels to 110 decibels. This is in relation to close-to-the-ear toys. Again, this is another change that aligns the new ASTM requirement with EN 71 Part 1. Next, we will focus on the revisions that affect ride-on toys, toy seats, and cord straps and elastics. For ride-on toys, again changes were made to align with EN 71. Products with wheels 150 millimeters or less apart would almost by definition be unstable. 150 millimeters is equivalent to around 6 inches. With wheels this close together, it would be difficult for the product to be stable as a ride-on toy, and therefore do not require testing in the new standard. Additionally, for ride-on toys and toy seats, the overload test has been revised for products designed to accommodate multiple children at the same time. Rather than testing each seating area individually at 3 times the manufacturer's stated weight capacity, the standard has been changed to a more realistic scenario that tests all seating areas simultaneously using a ×2 weight factor. The cord straps and elastics requirement was intended to address potential entanglement and strangulation hazards presented by toys intended for children under 18 months of age, where a cord or loop may be accessible to the child and subsequently placed around the neck. The new version of the standard exempts the restraints in ride-on toys from this requirement, as they are not readily accessible to the child. Additionally, these types of restraints have been on the market for many years with no incident data reported. Now we get into the really fun items, the ones that can be shot across the room. Initially, we'll start with the mouth-actuated projectile toys. These are projectile toys for which the projectile is launched by the user blowing into the discharge mechanism. An example would be a pea shooter. In the revised standard, the mouth-actuated projectile must include a permanently installed means to prevent the passage of the projectile backwards through the mouth end of the launcher. It means that if you inhale, then the projector cannot be sucked back into your airway. Keep in mind that as we talk about projectiles, we are referencing an object that is intended to be launched into a free flight. Projectile toys do not include self-propelled flying toys, such as a remote-controlled helicopter. The F963-16 standard has added definitions to provide clarity regarding the requirements for these projectile products. The definitions help differentiate between projectile toys or projectiles with stored energy and those without stored energy. A projectile with stored energy is a toy that is launched by a discharge mechanism capable of storing energy independent of the user. A good example is a rocket that is propelled by the gas that results from mixing baking soda and vinegar. Typically, the main hazards associated with projectile toys have been choking and eye injuries. For stored energy projectiles, the potential risk is greater due to the possibility of the projectile launching without notice. Projectile toys without stored energy require the user to take action to impart energy into the product in order for it to discharge the projectile. The bow and arrow that is pictured requires the user to pull back on the bow in order to launch the arrow. Similarly, products that launch foam darts, we used to call those guns, but that's not really appropriate terminology anymore. These products often require the user to pump the product and build pressure in order to shoot the dart. Additional revisions regarding projectile toys include clarifications such as defining the types of items that would not be subjected to the projectile toy requirement. Any toy that is typically intended to be on the ground or a component of those toys would not be tested as a projectile. As stated previously, projectile toys are intended to be launched in a free flight. Also, projectiles that travel less than 300 millimeters, which is around 1 foot, have been deemed by ASTM as being a low risk of injury due to the low risk for injury due to the lack of energy behind the projection. One exception to this is in relation to small part projectiles. For small part projectiles, the standard limits the travel distance of those projectiles to a maximum of 100 millimeters. This is relative to play sets where an initial action triggers the release of a small projectile, like a pretend boulder, that will travel relatively minor distances. We mentioned earlier that the main concerns regarding projectile toys are eye injuries and choking hazards. Previously, only rigid tip projectiles fired by a stored energy launch mechanism were required to be assessed using the pictured gauge. The standard was revised to require that all rigid tip projectiles, regardless of the type of the launch mechanism, be evaluated using the tip assessment gauge. All such projectiles should not go through the gauge. When ASTM reviewed incident data, they found that none of the darts involved would have met the existing EN71 Part 1 length requirement of 57 millimeters. In a continuing effort to align with other standards and provide a leading edge, the decision was made to align with the 57 millimeter length requirement in the EN71 standard. This is more of a concern with hard side projectiles. Darts with the foam shaft, as pictured, have not had similar reports of incidents, and an exemption has been included for these types of projectiles. Going back to projectile toys with stored energy, we want to provide more information about the force associated with stored energy. If the projectile has a kinetic energy exceeding 0.08 joules, then the projectile needs to have a resilient leading edge. What that basically means is that the edge has some flexibility to it so it does not easily break off or become an impalement hazard. If the tip can break off or come off, then it could become a small part or choking hazard. Additionally, there is a set level of the amount of energy associated with the launching of projectiles. The maximum kinetic energy per unit cannot exceed 2,500 joules per square meter. There have been many studies over the years of projectiles and the amount of energy that can cause damage to eyes based on this force. After careful consideration, ASTM has chosen to go with this conservative level in order to protect the public. As always, small parts need to be out of the environment of children as much as possible. The new standard allows some exemption for the small parts requirement based on the criteria here listed. This includes projectiles traveling less than 100 millimeters, small parts that are released after abuse testing that are either not capable of being launched or travel 100 millimeters or less when tested according to the projectile launch distance, and lastly, small parts of foam that are released from projectiles whose shafts are completely made of foam after abuse testing. Finally, the impact test for stored energy projectiles and arrows is addressed. There are 3 impact cycles, and the length is related to the 300 millimeters that we discussed earlier. This is the last slide in regards to projectile toys, I promise. Here we are focused on rotors on projectiles. The illustration on the screen shows good examples of protected rotors. The intent of this change is to prevent access to the blade ends during operation. There have been multiple incidents and recalls related to toys with unprotected rotors, and the hope is to provide best practices for manufacturers to follow to understand the parameters of how the rotors should be protected. As we discussed earlier, with the projectile tip, the rotor should also have a resilient leading edge. These same requirements are currently being discussed for inclusion in the projectile requirements for ISO 8124 Part 1. See, I told you we were done with projectiles. Let's move on to the squeeze toys and expanding material toys. To start, let's discuss squeeze toys. ASTM is addressing the scope of the impact test for squeeze toys. A squeeze toy would be subjected to the impaction hazard requirement. However, if the squeeze toy is attached to another toy, that other toy would not be subjected to impaction testing. This was really just a clarification to be sure that the applicability of impaction testing is clear. The expanding material toys have become very prominent in the last few years, with more and more items that start out small but that can grow into very large products when added to water. This new requirement addresses these toys which upon being swallowed can create a gastrointestinal blockage or other serious conditions. There have been reports of fatal and potentially fatal incidents where children have swallowed toys and other expanding household items. The expanding material needs to pass through the gauge in the picture. The gauge simulates the opening of the stomach, and the test requirement incorporates a minimal force value to simulate the muscular action of swallowing. To complete the section on physical requirements changes, ASTM has reincorporated the requirements for toy chests. These requirements were removed from the standard in 2011 but brought back for the 2016 version. Toy chests are defined as toy boxes that are designed and marketed as storage containers for toys and have a volume of 1.1 cubic feet or more. There's also a new procedure for testing the lid support mechanism. I won't read it to you, but the new standard wants to ensure that the lid can be safely held open throughout the complete arc of travel of the lid. This is to prevent sudden collapse or dropping of the lid. Next, we will cover the changes to the electrical requirements in the standard, focusing on battery-operated toys. Definitions have been provided for primary battery, primary cell, secondary battery, and secondary cell. A primary cell is a battery that is designed to be used once and discarded and not recharged with electricity and reused like a secondary cell. A primary battery is one or more of the primary cells. A secondary cell or rechargeable battery is a type of electrical battery which can be charged, discharged into a load, and recharged many times. It is composed of one or more electrochemical cells. 4 new test methods for toys that contain rechargeable cells and batteries have been added, including a battery overcharging test, repetitive overcharging test, single fault charging test, and a short circuit protection test. The new standard also clarifies that the requirements for secondary cells or secondary batteries do not apply to the main circuit of battery-powered ride-on toys powered by batteries other than lithium batteries. Lithium-ion batteries have been in the news a lot in the past year, most notably with hoverboards and their risk of exploding or catching fire, and most recently the concern with the Samsung Galaxy phones. F963-16 added a requirement for toys operated from lithium-ion or lithium-ion polymer batteries that they must comply with one of the following standards: ANSI C18.2M Part 2, UL 1642, UL 2054, or IEC 62133. Also, there are standards referenced for batteries charged outside of the toy. They must comply with ANSI UL 2595 or IEC 60950. You can show compliance with the cells or battery standards by providing appropriate documentation rather than having to undergo third-party testing. Finally, a brief note about the short circuit protection requirements that were added for both batteries and chargers in toys. These include new test parameters that were added to help prevent short circuits, which could ultimately lead to battery failures, fires, or explosions. Let's move on to the changes in the requirements relating to products with magnets. First of all, a new definition for magnetic electrical experimental sets has been added to the standard. It is a toy containing one or more magnets intended for carrying out educational experiments involving both magnetism and electricity. This definition replaced hobby, craft, and science kit type items. This new definition narrows the scope of products that could use the labeling exemption to only those products that combine magnetism and electricity, such as electrical motors, loudspeakers, doorbells, etc. These changes would more closely align the requirements in F963 with the requirements in ISO 8124 and EN 71. Additionally, the magnet use and abuse requirements have been expanded in order to further align with ISO and EN. This includes the addition of a soaking test for wooden toys and mouthpieces of mouth-actuated toys. This is intended to ensure that glued magnets do not come loose. As children put toys in their mouth, the saliva can start to break down the material, which could lead to possible separation of the magnet from the product. Another reason for this test is that properties of wood and wood toys can change with humidity levels. A compression test was added for products where the magnets are not accessible and cannot be tested by using the tension test, since the magnets cannot be grasped. A drop test was also added with the clarification of using a specific metal disc for cycle testing of toys that contain only a single magnet or magnetic component and no mating metal part. For use and abuse testing, the new standard notes that for magnets for use by children 8 years of age and older, you would follow the same process as for children between 3 and 8 years of age. Now let's talk about the changes to the requirements for button or coin cell batteries and magnet labeling. A new warning labeling requirement has been added for certain button and coin cell batteries that are of nominal 1.5 volts or greater than 15 millimeters in diameter, and fit within the small part cylinder to address hazards that have been identified with these cells. If ingested, these types of batteries are prone to become lodged in the esophagus, hydrolyzed by saliva, and raise the pH. This can cause chemical burns and a possible esophageal perforation. If the toy does not have instructions, then the label needs to be on either the packaging or an insert included with the product. The labeling should have the triangle with the exclamation point and warning in capital letters. This new labeling requirement clearly warns against the hazards of swallowing a battery and gives guidance to adults to help avoid such hazards. For magnetic and electrical experimental sets, they must have warnings on the packaging and in the operating instructions. Also, the safety alert symbol must appear before the warning statement. For the instructions requirements, we will focus on toy chests and battery-operated toys. For toy chests, the instructions for proper assembly and maintenance shall be provided in sufficient detail to describe the correct assembly of components, the resulting hazard if the lid support device is not installed, and a description of how to determine whether the support is working properly. For battery-powered ride-on toys, changes were made to provide guidance for the safe use and maintenance of the toy. The instructions must provide a maximum weight and/or age limit. They should also detail the surfaces where the products should be used, and warning statements should appear on the product with details about the batteries and chargers to be used with the product. With battery-operated toys, the change is related to removing the term nickel-cadmium from the standard. The focus of this section is to ensure that the instructions are clear to not combine different types of batteries in a product, as it might create an unsafe situation. The last section for today is in relation to the producer's markings requirements for toy chests. As we mentioned previously, ASTM F963 has brought back the toy chest standard into the F963 standard. The toy chest needs to be permanently labeled with the information for the manufacturer, distributor, or seller. A code to identify the month and year of manufacture will need to be included. Lastly, whenever the toy chest undergoes a significant modification or change, then the model number must be changed. This is the end of the presentation portion of today's webinar. We thank you for attending. At this time, we'd like to address questions that have come in through the webinar portal. We have a few minutes left, and we will try to answer as many questions as possible. So, Carolyn, the first question that we have is, how does ASTM F963-16 apply to items sold to schools for educational use?
Thanks, Chris. So generally speaking, items that are sold to schools would be considered non-toy children's products for the most part. And as such, they would be subject to the children's products regulations under the CPSIA standards rather than the toy regulation. And, to give a good example, you could have an item that might be, say, like a Matchbox car, but it is part of an educational kit to show the properties of potential and kinetic energy, just as an example. So, if you had something like that in an educational kit, it was being used by a teacher with children in a classroom setting. By the way the regulations are written, that Matchbox car would typically be considered a non-toy children's products. Of course, since it's sold at retail, it would be tested as a toy in that case. But I just kind of wanted to give an example of how something might appear to be a toy, but based on the use of the product would be considered by the regulation a non-toy children's products. But you do need to consider how the product is going to be used in the classroom setting to determine which standard would apply. For example, if we see a lot of situations where there's products that are designed for use in preschools, and their use is really in a play environment as opposed to just an educational environment. In that case, if the products are used in play, you would want them to meet the toy standard.
Great, Carolyn. Thanks for that answer. The next one I see is asking if we have any examples of what would be an expanded material toy.
Sure. You see these a lot in stores where you might see capsules that say that, grow a dinosaur. 100, the product expands 100 times when placed in water. So basically, a lot of these products are, like I said, in a capsule, like a gelatin capsule. You put it in water, the capsule will break down, and the foam toy inside will expand based on, the water hitting it. So for the most part, these types of foam toys, they're usually kind of soft, and when they expand, they would still be considered very pliable and be able to be pushed through that gauge that you mentioned earlier on in the presentation. The real concern here is products that will expand and have more of a rigid nature to them so that they can't go through that gauge and therefore would cause the potential blockage that you described earlier.
Great. Thanks. Our next question is in relation to, they're asking, is your laboratory accredited to test to the new standard?
Okay, well, the laboratory accreditation process will begin after the CPSC approves the new standard. As we said earlier on, the CPSC does have 90 days to review the standards, so they're still in that process. Once the new standard is approved, that will evolve into a situation where each lab that is currently testing, if they want to be accredited to the new standard, they have to then become ISO 17025 accredited to that new section. So once they get their ISO 17025 accreditation, that will be followed by them submitting the appropriate documentation to the CPSC for applying for CPSC accreditation. As we saw in the past, there may be a delay because there's so much going on, so much activity, and so many labs applying for accreditation. There may be a delay in the CPSC processing all of the applications in the period of time prior to the actual enforcement date of the new standard. So don't be surprised if there is a period of time during which the CPSC will accept testing by companies that may not be approved to the new standard yet, simply because there's a delay in the paperwork. So, this will be a wait and see process, but I, can let you know that as soon as we are able to, we will start the process of our 17025 accreditation to be fully prepared to assist our clients.
So Carolyn, those are the questions that I was able to see. I don't know if there's more, but for now, that's those are the ones we have.
Oh, okay. Well, if we do get any other questions through the portal, we will answer them via email after the webinar is over. So this concludes our webinar reviewing the updates for the ASTM F963 Standard Consumer Safety Specification for toys. We will be providing this webinar recording via email to all attendees a little bit later. So on behalf of Asia Inspection, we thank you for attending and we wish you a very happy holiday season. Have a great afternoon.